there are two ways of dealing with this type of equation, and that's because of how the expression on the left-hand side is presented to you. So let's quickly have a look at this left-hand side. First of all, it's an equation, a mathematical statement that says my expression on the left-hand side is equal to my expression on the right-hand side. The expression on the right-hand side is only a single constant, and the expression on the left is a bit more complicated. But it says that there's some value of y that would make this left-hand side equal to 6. We need to find out what that value is. On the left-hand side, how many terms do you see? One term. On the left-hand side, how many factors do you see? On the left-hand side, how many factors do you see? One factor. How many factors do you see?
I see 46.
You see 56 factors. You see 3 factors. How many factors do you see on the left-hand side? One factor. How many factors do you see on the left-hand side? 2. Are you saying 2? How many factors do you see on the left-hand side? How many factors do you see on the left-hand side? 2. How many factors on the left-hand side? 2. Shaban? 2. The viewer says 3. So I've got 1, I've got 2, I've got 3.
All around.
Raisa says it's 3 and it's the y minus 1 in brackets. Those are the 2 factors. Do you agree?
Yes, sir.
I agree. Remember when we learned about algebraic expressions and we learned about the language and how we use the terminology or how we read the expressions, we had a note about how to view brackets. Remember? We saw a bracket as one container, as one thing, and because it is not separated from the 3, this is seen as one term. But if you had to look at it in terms of factors, remember factors are separated by what? By multiplication. What is between 3 and the bracket? Multiplication. So how many factors do you see? 2. That's the 3 and the bracket. Now, would you agree with me that if I presented 2x to you and made it equal to 6, would you agree that I can use the multiplicative inverse there to find the value of x?
Yes, sir.
Because then I can get rid of my 2. Because the 2 is attached to the x by means of multiplication. So 2x is 2 times x. So to remove the 2, I need to divide by the 2. So I would say 2x divide by 2.
So x equals.
And then I would be able to isolate my other factor, which is the x, and make it equal to, of course, whatever's on the right hand side. Can you see that the form of this equation, the way it looks, is the same like this one?
Yes, sir.
In other words, eventually I would not want numbers on the left hand side, remember, because we want the variable to be alone. So I could, if I wanted to, remember I said there were 2 ways of doing this. I could divide by 3 already to get rid of it.
Yes,
Yeah? Like I would do there with the 2. So in other words, I would use the multiplicative inverse here because I could see the 3 as the coefficient of the bracket. And I'm asking you to think a bit further here now. Remember the 2 is the coefficient of the variable x. Here my variable is sort of locked into this bracket, but it's seen as one container and it's attached to a coefficient. Okay? So it's almost like saying if I could replace this bracket with, let's say, an x, then this would be 3 times x, wouldn't it be?
Yes, sir.
And I could divide both sides by 3.
Yes, sir.
Okay? So just bear with me. I know some of you is scratching your head. Just bear with me. So that what I'm saying is I could say 3y minus 1 divided by what? By 3, like I did there. And I would then divide 3 into 3. I can divide like this because this is a product. There's no plus or minus separating that, so I can divide. And I'll be left with what? Just the y minus 1. And this of course would be 2. Are we still together? Okay, just bear with me. I will show you the other way, of course, which is the way that I think most people will prefer. What do I need to do now to isolate my y? I would
Plus 1.
add 1 to both sides, right? So I would say y minus 1 plus 1. And I would of course say 2 plus 1 as well.
Y equals 3.
So that would be y equals 3. Yeah?